Welcome pre-cal students to class today on Tuesday the 3rd. Hope you guys are doing well. Hope you're ready to learn some math today. Let's quickly go over some announcements. There will be a test on Monday, so make sure you understand that. If you're not if you're not able to come over to my house that Sunday, please let me know, or that Monday, please let me know by Sunday. And that'll be your last test of the semester, not counting the semester exam. Your integrity sheets, don't forget when you walk in the door on Monday, what you have done is what you get credit for. So make sure you have everything finished at that time. And I need to hear from some of you still about your tests, so be in touch with me about your tests. And then also next week we'll start reviewing for your semester exam, and I'll have more information for you about the semester exam, how we're going to review for that, what day it's going to be, etc., as that time approaches. Okay? All right, excellent. Let's go ahead and get started. Get your pens, papers, pencils, books, calculators, notes, and let's have a really good class period today. First of all, let's quickly review what we learned yesterday, okay? Let's quickly review. Remember, I taught you how to write a vector in component form, and if the x comes first over here, xy, then that means your x is your initial point and y is your terminal point. And in order to write this in component form, you take the terminal point minus the initial point, which would give you -4, -3 minus 0, 6. -4 minus 0 would be -4, and -3 minus 6 would be -9. Okay, so we learned that yesterday. I'm not teaching you, I'm just reviewing, okay? And we also learned quickly how to do some calculations with vectors like u plus v. Well, that would be 4, 7. I just added my first numbers together, and then I added my second numbers together. Okay, so we learned that yesterday. We also learned, let's see, we have u right here. Hold on one second, let me fix what I did. There we go. Okay, now we also learned how to subtract vectors. So u is 7 comma 2, and then minus, and then notice it says 6v, so I took a 6 and I multiplied it through, -18, 30, and then 7 minus a -18 would be 25, 2 minus 30 would be -28. And then same thing here. I'm not going to go through number 3 and do that, but you would take 3 times u, and then plus 4 times v. And then after you've multiplied the 3 through and multiplied the 4 through, then you would add those two vectors together. And then last but not least, we looked at this right here. And that's where I will quickly work this one out. You take 5 times v, and 5 times v would be -15, 25. And then 2 times u, so minus, and then 2 times u would be 14 and 4. Do you see what I did? I went ahead and multiplied the 5 through v, and I got this right here. And then I went ahead and multiplied the 2 through u, and I got this right here. And then I would subtract these two vectors, so -15 minus 14 would be -29. All right? And then 25 minus 4 would be 21. All right, and that's basically it. And then it says, notice there's lines around this, and that means find the magnitude. So now I want you to find the magnitude. I'm not going to take time and do that for you, but it would be the square root of -29 squared plus 21 squared, and then go ahead and just work all of that out, okay? And by the way, in the last example I gave you right here, I forgot that it said find the magnitude. So to find the magnitude, it would simply be -4 squared plus -9 squared, and then you would go ahead and just work that out, okay? So a quick little review of what we did yesterday. All right, let me grab a quick drink here. And let's jump into the new material. Today we're going to look at 3 different topics. None of the topics are difficult. They're actually really easy if you'll just follow the steps that I give you and the formulas that I give you, but they are very important. First, we're going to look at how to find the dot product of 2 vectors. Second, we are going to look at what a unit vector is and how to find one. Thirdly, we are going to write vectors as a linear combination. All of those are pretty simple to do. Go ahead and write your heading down if you would, please. The first heading, we're going to have 3 different headings today. The first heading is dot product, and the lesson number is 7.6, and the date today, of course, is the 3rd. Dot product. When you multiply 2 vectors, you would think that you would get out another vector. You don't. You get out a number. Okay? Let me demonstrate. Let's say I took a vector like this, write this in your notes please, 4, 6 times, or dot product, however you want to say it, of this vector right here. They call this taking the dot product of 2 vectors. You could also say you're multiplying 2 vectors together. That's totally fine. And what you do is this. It's really easy, but you do not get out a vector. You get out a number. What you do is you multiply the first number times the first number. And that's easy. 4 times -5 is -20. Then you multiply the second number times the second number. So 6 times -3 would be -18. And then you add those 2 numbers together. And that's it. So you multiply the first number times the first number, you multiply the second number times the second number, and then add those 2 numbers together. If you're not good with your signed numbers, then use a calculator. And there's the dot product of those 2 vectors. Now students, that's pretty easy, okay? Let's practice on 3 of these very quickly. You can work ahead or watch me, that's up to you. Alright, here we go. Let's take the dot product of u times v. U times v. Vector u times vector v. Okay? Here's u, here's v. We're going to multiply first number times first number. 2 times 0 is 0. Then we're going to multiply second number times second number. That's -20. And then we're going to add those 2 numbers together. So 0 plus -20 is -20. There you go. Pretty simple. Let me grab another drink here. Okay, v times w. Well, here's v and here's w. So you multiply your first number times your first number and you would get 0. Then you multiply your second number times your second number and you would get 4. And then you add those 2 numbers together. 0 plus 4 is 4. Okay? Alright, let's find the dot product of u and w. U and w. Here's u. Here's w. Multiply the first numbers together. 2 times -3 would give you a -6. And then multiply the second numbers together. -5 times 1 would be -5. And of course we're going to add those 2 numbers together. So -6 plus a -5 is -11. Okay, so there we go. Part 1 of 3 already done. That's how you multiply 2 vectors together, or more specifically, to use the proper terminology, that's how you find the dot product of 2 vectors. Okay, and we're going to use that later on. It's very important you know how to do this. We're going to use this when we start finding the angle between 2 vectors. Alright, let's continue on. Now let's talk about unit vectors. Would you write that in your notes, please? Unit vectors, lesson 7.6, and of course the date still has not changed, obviously. Unit vectors. Unit vectors. Alright? A unit vector is a vector that has a magnitude or length, whatever you want to call it, magnitude or length of 1. Isn't that easy? That's what a unit vector is. It's a vector that has a magnitude or length of 1. I would like you to write this in your notes. I want to show you something you need to see. I want to show you what a unit vector looks like and how we know it's a unit vector. Here is an example of a unit vector. Now, I'm going to go ahead and draw this vector, and I'm not going to worry about getting the fractions just right. It's over 3/5 and it's up 4/5. So I'm going to go ahead and draw my vector. And I went over -3/5 and I went up. I'm just drawing a triangle for no certain reason. I'm just trying to show you I went up 4/5, okay? And we're going to find how long this line is right here, okay? So remember how to find the magnitude? We would square -3/5 and we would square 4/5. Now if you do that correctly, you will come out with 9/25 plus 16/25. And if you add those two together, those two fractions together, you will get 25 over 25, and of course 25 over 25 is 1, and the square root of 1 is 1. So this hypotenuse right here, or the magnitude, or the length, whatever you want to call it, is 1. And that's how I know this is a unit vector. Okay? Pretty cool. So a unit vector is just a vector that has a magnitude or a length of 1. Okay? Alright, let's continue on. Let's say that we have a vector -3, 5. Find a unit vector that is going the same direction. Now, first of all, you don't always have to do this, but I'm going to get a picture of it. And you don't always have to do this, okay? You can write this down if you want. You don't have to. It's totally up to you. So there's my vector, okay? Now when this problem says find a unit vector that's going the same direction, all that they're saying is this. Please watch carefully. They just want to know how far up to go on this vector so that you have a length of what? 1. That's it. That's all you're doing, okay? And you say, well, Mr. Earhart, obviously you go up to you have a length of 1. I know that, but I mean they want to know the ordered pair. So they want to know how far over you go and how far up you go so that you have a length of 1. And that's all that we're going to do. And it might seem hard to you, but it's really actually a pretty easy formula that we use. And the formula is this. You take your vector, we're going to call it vector v. We're going to say vector v, of course it could be any vector, but we're going to say vector v divided by the magnitude of v. Okay, let's pretend this vector was called v. Now it could be any letter at all. It doesn't matter what letter you have here. It doesn't matter what letter you have here. But if you will use this formula right here, vector v over or divided by the magnitude of vector v, if you'll use this formula, it works every time and it's really easy. So first of all, let's find the magnitude of vector v. Okay, the magnitude. So here we go. -3 squared plus 5 squared. So I would then have the square root of 34, because 3 times 3 is 9, 5 times 5 is 25. Add them together and you get 34. So what I have is vector v over the square root of 34. Does everybody see that? The bottom of your fraction and this formula says find the magnitude of the given vector. In this case we called it v, and the magnitude of this vector was square root of 34. Now, how do I take a vector and divide it by a number? Well, you just take each number and divide it by square root of 34. So my first number is -3, so I would have -3 over square root of 34. Then put a comma, and then your next number is 5 right here. So you would then put 5 over square root of 34. And that's it. That's your unit vector. So what you just found is you would go over, and I'm not sure what that decimal would be. Now you want to leave your answer like this, okay? But I'm just kind of curious what the decimal would be. 3 divided by second square root 34. It would be -0.51. Of course I rounded. And then 5 divided by the square root of 34 would be 0.86. So what we learned there is if you go over about a half, so right there, and then up almost a whole, about right there, it's real teeny tiny, but there's your unit vector right there, that dot right there, okay? And so you found a vector that has a length of 1 that's going the same direction as this vector. Oh, and by the way, you know how I've drilled into y'all's heads to always rationalize your denominator? In other words, multiply the top and the bottom by the square root of 34 in both of these fractions. You do not need to do that. I don't know why. I'm not sure why, but I know in all the textbooks I've ever used, including this textbook, they do not make you rationalize denominators when you're finding unit vectors, so you are more than welcome to leave your answer like this. Okay, let me grab a quick drink here. Let's practice a couple of these if we would. Let's find a unit vector going the same direction as 3 or 4. You can watch me or you can work ahead. Just to use a different number so you get used to that, we're going to call this vector W. Vector W. So the formula would be W over the magnitude of W. So all we have to do is very quickly find the magnitude of W, which is 3 squared plus 4 squared, which would be 25 inside your radical, and the square root of 25 is 5. So my denominator is 5, and I still have W up top. Okay, so the magnitude of W is 5, and now I'm going to take this vector and divide by 5. So my first number is 3, divide by 5, and you would get 3/5. My second number is 4, divide by 5, and you get 4/5. Do you know why this form, and by the way, there's your unit vector right there. That's going the same direction as this vector here. Now, do you know why this formula works? I'm going to tell you why it works. All that you're doing is you're taking the entire length of W, the whole magnitude, and then you're taking the actual vector itself and you're dividing it by that length. Okay, it's like taking a percentage, and by doing that, that's going to obviously give you a length of 1 for your magnitude. Okay, that's what you're doing. All right, let's take a look at, did I only give you one of those? Okay, well, that's fine. Here's another one here. Let's quickly, before we look at our third topic, I want to review what we've done so far today. All right, so you can take notes on this or you can just watch. That's totally up to you. Okay, earlier this class period, we learned how to find the dot product of two vectors. So we're multiplying two vectors together, and I taught you to take the first number times the first number. That would give you negative 20. Take the second number times the second number. That would give you negative 80. And then we're going to add those two numbers together. Negative 20 plus negative 80 would give you negative 100. So there you go. You just found the dot product of two vectors. Here, I just taught you how to find the unit vector I've taught you how to find the unit vector that's going the same direction as a given vector. And what I just taught you to do is to find the magnitude. So 6 squared plus negative 7 squared. And of course that would be 36 plus 49, which would be the square root of 85. Now if we could break that down, I would, but you cannot break that down. And so now what you do, remember, you take each number here and you divide it by the square root of 85. So your first number is 6, so 6 over the square root of 85, comma, and then your second number, which is negative 7 over the square root of 85. So you just found a unit vector going the same direction as this vector here. Okay, I really don't think the math has been too difficult at all today. It's been pretty simple. Okay, and now our third topic, writing vectors as a linear combination. Please write this in your notes. Writing vectors as a linear combination. Writing vectors as a linear combination, lesson 7.6. First, understand that a vector, are you listening? Watch this, cannot be written in linear combination unless it is first written in component form. You must first write the vector in component form. After a vector is written in component form, it is very easy to write it in linear combination. Okay? Now I would write that down, but that's up to you. Let me demonstrate. Here's a vector. If I ask you to write that as in linear combination or as a linear combination, notice the vector is already written in component form. See the arrows? This vector is already written in component form. Do you know how to write that as a linear combination? There. It's that easy. You take your first number, -2, and you put the letter I with it. You take your second number and you put the letter J with it. And of course you got to put your sign. So if it's positive, you put a positive. If it's negative, you put a negative. So it's basically like two terms in an algebra expression. Let me get a quick drink here of some coffee. So your basic looks like an algebra expression with two unknowns, I and j. But that is how you write a vector as a linear combination. Now, why I and j? I don't have an answer for that. I will say this though. Some textbooks do use different letters. Most do not. In fact, I've only used one. I'm thinking it's Saxon, but I could be wrong. So don't hold me to that, okay? I think Saxon has two X's, I don't remember. But anyways, I've only used one textbook that used different letters, but all the other textbooks I've ever used always use I and J, okay? And so that's all you have to do to write a vector as a linear combination. Now that's easy. So let's practice a couple, okay? All right, I want you to take a vector CD, and I want you to write it as a linear combination. Now notice first of all, C is your first letter, that's your initial point, and D is your second letter, that's your terminal point. Is this vector written in component form? No, it is not. Absolutely not. So look at my comment up here. You cannot write a vector as linear combination unless it is first written in component form. So we must first quickly take our terminal point minus our initial point. And when we do that, that will give us component form. So my terminal point is 5, 7. So 5, 7. My initial point is 1, 5. And we're going to subtract them. 5 minus 1 is 4, 7 minus 5 is 2. So there, I took vector CD and I wrote it in component form. And now I want you to write this vector as a linear combination. So your first number is 4, so 4i, your second number is 2, so plus 2j. So this is a new form of a vector, okay? This is a vector here written in just standard normal form. This is a vector here written in component form. And this is a vector here written as a linear combination. Okay? All right, let's try one more. You can work ahead or watch me. I want you to write this vector as a linear combination. Now notice first of all it is not in component form. So my first letter over here is G. It's vector GH. So G is my initial point, and H is my terminal point. Now, I'm going to do this in my head. We've done so many of these now, we should be good with this. You take terminal point minus initial point, so it's -3 minus a -6. -3 minus a -6, and that would give you 3. And then we have 2 minus 10. 2 minus 10, that would be -8. There we go. And now, that's component form. Now I want you to write this vector as a linear combination, 3i minus 8j. There we go. So I took a vector, I wrote it in component form, then I wrote it as a linear combination. Now that's pretty easy. And also, doing calculations like this, oh my, it's so easy, guys. Look at this. Let's whip through these really quick. Oh, Mr. Garrett, you said 3 topics. Well, this is still linear combination. I mean, my goodness, adding 2 of these together? Come on, guys, think of this. We're adding u plus v. So here's u, here's v, and we're going to add them together. So you add your i's together, 2i and -10. That gives you -8i, and then add your j's together, 3j minus 3j, that would give you a 0j. And there's your answer. You added 2 vectors together. Now, if you don't want to write the 0j, you're more than welcome to just write negative 8i for your answer. That's fine. No problem with that whatsoever. Okay? All right, let's take a look at this here. Here we have 2u plus w. Okay, I can quickly multiply 2 times u in my head. So 2 times u, 2 times 2i would be 4i. 2 times 3j would be 6j. So I took 2 times u and I got this and now I'm going to add w. So plus w. So I'm going to add this right here. I'll go ahead and bring it down. I plus 8j. So we're going to add these two together. 4i plus I, well, that's going to be 5i. There's a 1 right here in front of the I, even though you can't see it. And then 6j plus 8j, or yeah, 6j plus 8j would give you 14j. There we go. Okay, really, really pretty simple stuff. And then lastly, okay, I'm going to take 2 times w. I'm going to kind of do that in my head. Here's w up here. 2 times I would be 2i, and 2 times 8j would be 16j. So there we go. All right, and then 3 times v. Well, here's v. Take your 3 and multiply it through. 3 times negative 10 would be negative 30i, and then 3 times negative 3 would be negative 9j. Okay, now don't forget, there's a minus sign between these two vectors. Did I lose you there? Watch carefully. I took 2 times w and I got this right here. Here's 2w right here. I got this right here. Okay, then I took 3 times v and I got this vector right here. Everybody see that okay? Now, some students would like to multiply the negative 3 through and then add the two vectors, and that's totally fine. You can do that. You get the right answer. I did not multiply a negative 3 through. I did not. I just simply brought over my negative sign and I multiplied a positive 3 times v. Either way is fine. It doesn't matter. And now we're going to subtract the two vectors. 2 minus a negative 30. Well, that's 32i. 16 minus a negative 9. Well, that's 25j. And there you go. That's it for the whole class period. I hope you've understood the math. Call me or email if you have any questions at all. Please get started on your homework right away. If you were in a normal school, if you were in my class, the normal school, I would give you 15 to 20 minutes to work on your homework. So go ahead and get started. This is a typical problem. You've got about 18 problems to work on. I think they'll go very fast for you. Shouldn't take you more than probably 15, 20, 25 minutes, something like that, which is a normal homework assignment. And please get to work. There's a video to watch if you need help with your homework. Work hard. Call me or email if you have any questions.